Hello, welcome to episode number 23. So, a car moving in a straight line passes through 2 points A and B. Let's make a sketch of that line. So, if I have this is the point A and the point what B, which are 128 meters apart. So it means the distance between them is 128 meters from here all the way there, which with the speed 72 and 56 meters per second respectively. So the first one have initial velocity of 72 meters per second. The second one has initial velocity of 56 meters per second. So we have to calculate the retardation, which is acceleration. We are looking for the acceleration of the body that is traveling in this way. So we can have our acceleration, which is unknown. In this case, it's deceleration because the velocity is reducing from 72 to 56 is reducing velocity, therefore acceleration become negative. So the value we are looking for the acceleration need to be what? Negative. So let's see what information we have. So velocity, we also have acceleration, we have what? Distance. So this will be a perfect time to use the third equation of motion. So we have from v square u square plus 2as. I think this is also basically just equation of motion, not necessarily under gravity. So we have this. The body starts from here as initial and end here. So this becomes the final velocity, even though it's an initial velocity for where the body will get to B. Because when it get to B, it's going to bypass B. So that is also an initial velocity. So I can have final velocity from that place as 56 square, initial as 72 square, plus 2 acceleration times distance, 128 times what? A. Let's see the value we can get when we square 56, and this will be 3136. Then 72 times 72, 5184. 2 times this will be 256 what? A. Let's do the grouping of like terms. We still maintain 256A. And if you subtract 3136 minus 5184, you should be having negative 2048 equals to 256A. So your A will be negative 2048 divided by 256. Let's see what that will be. And that will give us 8.1 meter per second square. I think this is negative, so we have negative 8.1, and that shows the retardation. So therefore, the retardation is going to be negative 8 meter per second square. That is the first part. I think I can still label this as the first part. Then we are going to the second part. Distance beyond the second point B at which the car comes to rest. So if we are going for the second part, let's say we have this. This is where B is. The body now coming to rest. So at rest, what will happen? The final velocity will now become what? 0 meter per second what? Per second. It becomes 0. I think, yeah, 0 meter per second. The initial is going to be 56 meter per second. The distance is what you are looking for. The acceleration will still remain the same negative because it's a retardation. It's a constant. So it's going to be the same acceleration along the line. So these are the information we have. We can still use this initial, final acceleration, then we can find the distance. So we can still have from v squared u squared to as. This is the final velocity in there at 0. Initial at 56 squared. 2 times -8. Then the s will come. So now let's bring all of these together as positive 16x equals to 31, 36. This is our x, right? So x will now become 31, 36 divided by what? 16. Let's see what that will be on our calculator. And that will give you 196 meters. So the distance beyond B, where the body will now come to rest, is going to be 196 meters. So the final one is, we are looking at for the time taken to cover the distance in B. What will be the time here? Initial velocity, final velocity, acceleration is known. So we can consider and find the time using the first equation. We can make use of the first equation, as in from v equals to u plus what? At. Final initial time is what you're looking for. Acceleration is known as a uniform retardation, so we can easily find the time using this. So here we can say v is 0, u is 56, a is -8. I think the unit, okay, I will indicate the unit. Okay, let me indicate meter per second square. So 0 equals to 56 plus -8 times t. So this is coming here as 8t equals to what? 56. T will now be 56 divided by what? 8. And that gives us what? 7 what? Seconds. So what are we looking for? The time. Therefore, the time taken to cover the distance beyond B is going to be 7 seconds here. We have our distance to be 196. All right, I guess the concept is clear. This is not actually a question under motion, as in motion under gravity. This is a normal equation of what? Motion. I started solving before I realized this is not exactly motion under what? Gravity. But I guess concept is clear. Like, share, comment, and subscribe.